Hello pre-algebra students, this is our video on relations and functions. So we're getting into coordinate plane algebra. So it's like algebra and geometry together, kind of, actually, if you think about it. So let's start with a brief review of what some of you may have missed on the coordinate plane. So when we're graphing on the coordinate plane, we're talking about a grid graph, as you see here on the right. And we're talking about one where you have a y-axis, which is vertical, and an x-axis, which is horizontal. Together they make up the axes. The origin is the point 0, 0. And to find points on the coordinate plane, you use ordered pairs x and y, and those ordered pairs give you the horizontal and vertical component of the location of a point. So the quadrants that you see here, quadrant 1 is positive for x and positive for y, so that's where ordered pairs that are positive, positive would be. Quadrant 2 is negative for x, so you count negative 1, negative 2, negative 3, just like a horizontal number line. So negative for x and then positive for y, that's quadrant 2. And you can see the point B right here. Capital letters are used to locate points in the coordinate plane. Then you have the third quadrant, which is negative for x and negative for y, down here. And then the fourth quadrant, which is positive x and then negative y. And you can remember that by drawing yourself a big C for coordinate plane, and that helps you remember that that's the way that you number the quadrants. Called quadrants because there are 4 of them, quad. Okay, so let's move on with... So now we go on to talking about what constitutes a relation. What is a relation in mathematics? Well, a relation is a set of ordered pairs of input and output values. And those ordered pairs are normally represented in the form x then y, like so, with parentheses around them and comma in between. What are some characteristics of a relation? Well, there are multiple ways to display a relation. You can display a relation as a set of ordered pairs, as a table, where you have x and y both listed and they go together in ordered pairs, as points on a graph, where you actually graph them on the coordinate plane, as an equation that relates the two together, which is where we're headed, and that's kind of the goal of what we're doing, or in words, in a sentence. So that would be like a real-life example of a relation between the x's and the y's. So let's look at a couple of examples of how we can show this. So you would see it written in this format. So you'd see like ordered pairs surrounded by the curly braces, or a table where it says input and output, or it might actually say x and y instead of input and output. And then finally, what are some non-examples? So what are we not talking about here? What a relation is not is it is not just a variable. It's not an expression. So when we call it a relation, that doesn't necessarily mean that there's something going on with it in a specific mathematical sense. So it could just be some set of ordered pairs where someone took and made dots on the coordinate plane. And it's not a constant. It's not just one number. So it's got to be ordered pairs. Let's go a step further and be more specific. What is a function? Well, a function is a specific kind of relation. Let's define it. So a function is a relation where each input has exactly one output. So you can't put in the same number 2 times and get 2 different outputs. Every number you put in gives you something different out. So, in a visual sense, what is a characteristic of a function? Well, no 2 points will share the same x value on a function. So that means that it will be impossible that if you have a graph of the dots, pretend that's a straight line, goodness. If you have a graph of the dots on a function, that none of them will have the same x value. If they do have the same x value, those 2 points that share that x value, they're on the same vertical line together. And that means they fail the vertical line test. Oh, fails the vertical line test because it has 2 points that have the same x value. Why is this what a function is? I want to go over that in class. So right now I just want you to get definitions and examples and things down. And this is a pretty cool way to do vocabulary too. So I want you to make sure you're getting this down. Now let's do a couple of examples. And actually, I really only made one example. I just made it 3 different ways. So here is a function, where a specific relation where each value that's going in comes out with a different value from y. And you can see that it's, in this case, going to be a linear function at that, because it's going to make a line. All right, so that gives you a good idea of what a function is. What is not a function? Or let's do a non-example of a function. So here's a mapping of a relation that is not a function. So it is ordered pairs, 3, -5, 3, 2, and 4, 7, but this 3 is being used twice. That means they'd be on that same vertical line together. And then this right here, this is an example of a relation. This is a relationship between x and y. Like we said, a relation is a set of ordered pairs. In this case, a curved one that keeps going from both branches, I should say, this way and this way. But you can see that, indeed, it would fail that vertical line test. Fails the vertical line test. So that's not a function. So those are our non-examples. Now on to the parts of a function. The domain is the set of all the x values in a function. So you can use this acronym. Domain is the set of all the input values of the function. That's the x coordinate, so the set of all x values, so dix or dix. And then you have the range, which is the output or the set of all the y values, so dix roy. And that's one way to help you remember. And to help you remember that its domain is x and range is y, I like to write it like so, because that helps you remember x sits on the line, just like the word domain, and the y dips below the line, just like the word range, the G in the word range. So dix roy, the domain is the input, the set of all x's. The range is the output, the set of all y's. And we can show a relation or a function in multiple ways. So let's go ahead and show that here. There's 4 different ways to show a relation. So I'm going to write down a set of ordered pairs, and I want you to draw the table, and I want you to try writing in what you think each one is. Or if you want to wait, you can also, of course, play it, because I will still write it in for you. So here's the set of ordered pairs. And there's the set of ordered pairs. So to write it as a table, you're going to write x and y in order, of course, left and right. And then you're going to take the x's and put them in numerical order. So we have a -2, we have a 0, we have a 1, and we have a 2 for the x values. For the y values, of course, don't move those around. Keep them side by side with the numbers they actually go with in their ordered pairs. So 3 goes with -2, -4 goes with 0, 3 goes with 1, and 0 goes with 2. The graph, of course, pretty simple, pretty straightforward. We've done this before, I'm sure. So you want to go through and you want to find each ordered pair. So -2, 3. So take your ordered pencil, start on the origin, -2 for x, so to the left 2, and then 3 up. And there's the ordered pair that we want to graph right there. Make them nice and obvious. All right, next one, 0, -4, so right down here. Oop, that one's a little lopsided, but that's okay. And then the next one is 1, 3, so to the right 1, 3 up. Oop, I was off a little there. To the right 1, 3 up. There we go. Okay, and then 2, 0. So to the right 2, and then 0. So right there on the x-axis. All right, and there's our 4 ordered pairs. Now, what's a mapping? A mapping is this interesting thing that you see that looks like so, with 2 ovals. The x side looks just like the table version of the relation, but the y side is in numerical order like the x side is. And I'm just going to clean that up a little bit. There we go. And then you draw arrows between the numbers that go together. So -2 goes to 3. 0 goes to -4. 1 goes also to 3. And 2 goes to 0. So that's a mapping with the 2 ovals, and then you write in order the arrows for the ordered pairs. Now to write the domain and range is actually really simple. Just look at your mapping. The domain is the x's, -2, 0, 1, and 2 in numerical order, and the range is the y's, again in numerical order. So is this a function? So that's the big question here. Which is it? Is it just a relation or is this a function? Well, I can tell you from the vertical line test that there is no place that I could draw a vertical line on this anywhere across the function and touch 2 points. So it passes the vertical line test. Okay, so therefore it is a function. And we can also take a look at the mapping and look at how there's no value in the first oval in the domain that has 2 arrows coming off of it. See, 1, 1, 1, 1. Okay, so it's definitely a function. So the last thing we're going to talk about in this video is what a function rule is. So now we go back to it looking a little bit more like what we've been doing, which is equations. So a function rule is an equation that has an input, which is x, and an output, which is f of x. So each part here needs a label. So let's go through and let's label this. Let's fill this in. F is the name of the function. So f is function of x, but sometimes they use other letters like g of x or h of x. Okay, but in this case, the f there, that's the name of the function. X right here, that tells us what number to plug in for x. So to plug into the function. So that tells us what number to actually plug into the function, which is this part right here. So what you actually do with x is the actual function. So in this case, it's 3x plus 4. So that's the actual function, the function. Okay? When we look at this right here, we pronounce that, or we read that f of x. Okay? And that means the same thing as y. That's the output. F of x is the same thing as y. That's the output of the function. So let's take a look at what a couple of these look like when we actually go ahead and evaluate them. So we have our f of x equals 3x plus 4. That's the function rule. So we're actually going to go ahead and illustrate what it means to do f of 2 and f of negative 1. Well, remember what the function is. The function is 3x, right here, 3x plus 4. So 3x plus 4. So that means 3 times whatever x is plus 4. And we're going to bring in a 2. We're going to find f of 2. That means plug in a 2 for the x. And that means that we're going to actually do the math of 3 times 2 plus 4. So 3 times 2 is 6 plus 4. That's going to come out, that's 10. So that means f of 2 is equal to 10. If I evaluate this function at 2, I get an answer of 10. Let's do the same thing over here. Plug in the negative 1. So you take your function rule, you replace the x with the value you're plugging in. This one's negative 3 plus 4. That comes out a positive 1. So that means f of negative 1 is equal to positive 1. And that's a function rule. And you will work on evaluating function rules the next time you come to class. So I will see you guys in class.